So I'd like to introduce our next keynote speaker. One thing we were kind of surprised at ClearEdge, and we did a lot with Accumulo and Hadoop in government spaces and started to branch out into commercial, was the adoption of Accumulo by various commercial entities. So in keeping with that vein, we wanted to get a keynote speaker from the commercial realm, like we did last year. So this year's speaker is Skan Gupta. He's an engineering manager at Bloomberg. He's going to speak to you about Bvault, which is Bloomberg's one of their key search things, and Accumulo is one of the key components of that. So I'll go ahead and turn it over to Skan. Thank you.
Thank you. So for the record, and thank you. So for the record, Bloomberg doesn't use Accumulo. So I'm an engineering manager at Bloomberg, and what I wanted to talk about how we use Accumulo and why we decided to use Accumulo. So I'll spare you the marketing mumbo jumbo, but what I want to start with is a story that broke out in 2008. So Wall Street Journal reported in 2008 that some key banks are reporting false LIBOR rates or are actually fixing the LIBOR rates. So LIBOR rate sounds like one of those terms that financial industry creates to put you to sleep, right? But it's actually very, very important. What it actually means is it's the average interest rate that a bank pays when it wants to borrow money from some other bank. So Bank A wants to borrow money from Bank B. The LIBOR rate determines what's the average interest rate that these banks are paying. And it has two major significance. One is that it's kind of it's a metric of the financial health of a bank. So if a bank pays lower interest rate, what it means that its peers thinks that's in a good financial health, right? And the second, or more importantly, is that it's the basic rate that's used by a lot of lending institutes to determine what's the interest rate that consumers or businesses should be paying. So let's say you want to buy a car, you want to take a mortgage. The lending institutes use LIBOR rate as the basis to say what is the interest that you are paying. So if there's a higher LIBOR rate being reported, you'll pay more interest rate, and so on and so forth. So there's significance to that. It's also, there are $350 trillion worth of financial products that's actually based off LIBOR. So it's a very important number. And to put that into perspective, a total output across all the world was close to, I think, $65 trillion. And obviously, its financial market can multiply that multiple times. So that's about $350 trillion of products right on the LIBOR rate, right? So after Wall Street Journal reported this, there was a multi-year investigation on this, and a bunch of banks were found guilty of fixing LIBOR rate. So in 2012, Barclays Bank paid $200 million, agreed to pay $200 million as a fine for this. As latest as last week, Deutsche Bank agreed to pay $2.5 billion for their role in fixing LIBOR rate. And here's the most interesting part where this community comes in, right? All of this fixing, the price fixing, happened on written communication. That was as naive as that. So CFTC released some of the transcripts for the Deutsche Bank LIBOR price fixing, and this is a snippet of that, right? If you can read it, focus on like this one conversation where there's a trader in the bank asking for higher LIBOR rate, right? And these are the traders who are trading on currency, and there's this guy, the other guy who's involved in reporting the LIBOR rates to the authorities. So he's asking for higher LIBOR rates. This guy says, no, it shouldn't be. And the first guy says, we always need higher LIBOR rate. So second guy is like, okay, sure, I'll see what I can do. I shouldn't say the whole thing, but this is there in written communication. This was released by CFTC last week, and there's a whole transcript. It makes for a very interesting reading. So the point being, this is all there in the data, and like people need to understand what's going on this data, right? What they need to understand, it's not a choice, right? There's all of these companies building interesting systems to analyze their click-through because that translates into real money for them. But these kind of things, when people don't look at communication, or it's really difficult to look at communication and they ignore it, it can lead to pretty significant financial losses for the companies as well. So one of the things that we do at Bloomberg and my team is to build a system that tries to generate some insights out of all the data that's sitting out there. That's the data generated within Bloomberg. That's the data generated by our customers. So what we try to do is to kind of answer or like find some useful insights in the data. So you want to figure out what is the trend in the data that's going on, right? Who are people talking to, for instance? What are the hot topics in the data? So you want to generate those insights. So what our system does is takes all of this data. On the left side, if you see, I don't know if it's very clear or not, but that's essentially all of the different data type that we can suck into our system. For each of the different data types, you can define what kind of analysis that you want to do, right? Or what kind of processing that you want to do. So for example, on an email data, or when you're talking about IM data, a company might have policy to say trader A from bank A shouldn't be talking to trader B from bank B. During trading hours, or it could be way more complicated. You want to look at the data itself and see what's going, or do some analysis on the data. So that's what the systems that we have built tries to do. We also do kind of real-time analysis on the data. So as email is generated in Bloomberg's messaging system, it comes through our system, and we do policy checking on that. And based on whether the data, whether the policy check passes or fails, we either allow the communication, or we block it, or we warn, or whatnot, right? So you can do real-time analysis on this data, as well as after the fact checking on the data as well. So where Accumulo fits in is right here in our data pipeline. So if I zoom in a little, zoom in a bit, this is what our system looks like. So we get all the data that's generated in Bloomberg, and for our customers, we have a Apache Kafka as the gateway for all of this data, and then we have Storm topologies which read data from a Kafka and apply some processing. And this is where in our Storm topologies you can use them to define like custom processing for the different types of data. So you can take the email data out. There's a Storm topologies which says, what should I do with this email data, right? It could be like one of the rules you can specify in these topologies that you want to do real-time compliance checking on this. So that's what we do. And then with different data types, you can apply different topologies. We process this data, and we store all of this in Accumulo. Right, so that's where Accumulo fits in. And now the more interesting, and after this data sits in Accumulo, what we built APIs on top of that to do more computationally intensive calculations on top of that. And so there's an API, that gray bar at the top is the API, and on top of the APIs are all different applications that we built. So there's search, there's compliance console, there's aggregation of the data, all that kind of a thing, right? Right. So one of the things that we want, one of the key reasons why we picked Accumulo is the amount of data that we are storing in our system. So these two charts show the data that as we store and its growth over the years. I was not allowed to show the real number, so I had to kind of fudge these graphs a little. But the left one shows the yearly growth in data. So this is about, at this point we get about many hundreds of gigs of data per year. And on the right side is the cumulative data growth. And that's important because as a platform, we don't throw away any data whatsoever. If you send data to us, we keep it unless you ask us to delete it. And most people keep the data forever. Right? So at this point, we have about 3 petabytes of archive data, and we also index about 80 billion objects in our data in our system. Right? We do about real-time policy checking or real-time checking on the data. For about 35 million of these objects, we do real-time compliance checking as well. So one of the reasons where Accumulo fits in very nicely is it can handle these kind of scales or these kind of volume of data very easily or relatively easily, right? Now, one of the things that's also very important for us is the cost of storage, right? Now, in this world, the cost of storage, people tend to discount that a little, because I think as of 2014, average consumer grade hard disk, if you want to buy, the cost of storing a GB of data is about 4 cents or something like that, right? But in enterprise, it's slightly different, right? So if I take the list price of storing data, this is like if you buy an enterprise grade hard disk, the cost for you to store a GB of data is about 19 cents. Now, you might have good people who can negotiate better rates, and you can get 10 cents and whatnot, but that's not important for this discussion, right? So let's start with that list price. Now, obviously, you always want to replicate the data, right? So if you take HDFS, if you're storing the data in something like HDFS and you do default replication of 3 times, then the cost of storing that data becomes 3 times. So it goes to about 58 cents to store 1 GB of data. Now, if you are as paranoid as we are, we say we want to store the data not in one data center, but in multiple data centers, at least 2 data centers. So if there's another Hurricane Irene or Sandy and our Manhattan data center goes down, we still have the data available and our customers can use it. So then the cost doubles up. So now you're storing, the cost of storing 1 GB of data becomes $1.15, right? And the last part is very interesting for me, for us actually. What I mean by isolation is the kind of data that we get. Let's talk about an email, right? So you have one sender, you have multiple recipients. And in our case, so there's a bank, the sender could be from bank A, recipient could be bank B, C, D, and E. Now, if all of the people are our customers, this email belongs to each of those, right? So bank A, bank B, bank C, bank D, they all own that data. Now, if you want to store like a copy of email for each of the banks, because each of the banks might have different retention period. Bank A might want to store the data only for a year. Bank B might want to store the data for 5 years. So there's a cost in separating or isolating the data, right? So if you want to do that, then the cost doubles up again. So now that 19 cents per GB storing the data actually becomes $2.31, right? So you can't really do anything about these 3, right? You want to make sure there are some copies of the data. You want to make sure that your system can run when there's a disaster. So really can't do anything about these 3 numbers here. But you can actually save on this last number, right? If your data store can provide good security primitives, then you can actually say or convince yourself that it's okay to store the data together, as long as I can guarantee that I'll never deliver one customer's data to some other customer. If that happens, my job is gone for sure, right? So that's really, really important, and that's where Accumulo fits in as well. So for us, there's actually 3 levels. There's a security requirement goes 3 in increasingly more granular levels, right? At the highest level, it's the company level security. So this, if I simplify the whole diagram, this is essentially on the left is your data pipe, followed by a data storage system, followed by application and a bunch of users. And these 3 lines, different color lines, represent the data flow for each customer, right? So what you want to make sure that these lines never cross. So user A never sees user B's data. That cannot happen. Second, at a more granular level, within a company's data, different users might have different like permissions to view different subsets of data. So user A might just see those 2 blocks. There might be a super user who gets access to all of this, right? Where it gets even more interesting is within a document you can have different views. And that's our use case that we need to actually fulfill, is at a token level itself, you might have visibility or security requirements. So where given email, some user can see a part of the email, other user might be able to see the full email. So and we need to do that. And in past, we have actually used a bunch of different techniques to kind of solve this problem. One very popular technique was always post-process the queries. So you send out the queries, you get back the result, and in the client side, you have logic to filter. You can see the problem with that, right? One, it's slow. You are transferring all of this data across the network where you don't need to. And two, it can lead to nasty bugs. And we have had problems there, right? You could generate unique views of the document. So given a document, you know that I need 5 or 10 different views of it because different people have different access to this data. So you can say, I can create all those views and store it, and then just use those views to serve out the results, right? That doesn't work for obvious reasons. It just grows. The data grows exponentially, and the amount of data you need to store grows exponentially. You can use some application-specific features. So one of the things that we do is we get all of this data, we index it, we store it, and we use Solr for indexing. And we've tried a bunch of techniques with Solr dynamic field, mangle fields, and all of that. And some of those work really well. And we presented some of these techniques at Lucene conference last year, Solr Revolution last year, and that works. But the problem is it's application specific, right? So now I have to implement this in my search index. If I have to implement this in my compliance console, I have to implement this on any application that I build on top, right? And that's where, again, the power of Accumulo comes in. It's that one, it's server-side security. It's fast, and it's generic. I can sleep peacefully saying that the data is being, irrespective of any application I build, Accumulo is going to look for the security or take care of the security for me. So that's very, very useful. You obviously want to be a little more paranoid and add an extra level of security on the client, on the application side as well, and we do that too. But it's good. It's a very good thing to know that the database is taking care of the security for you, and that's that's a prime reason why we picked Accumulo for our use case. Right. So quickly, some of the, so we do a lot of range scanning on the data, date-based discovery of the data. So this is one of the tables that we store. So the keys is essentially, row ID is essentially, we take a company a user A for the company, and then we append date to it. So this is what one of the table looks like. So an Accumulo obviously sorts it, so you get a nice sorted key on this data. So let's say you want to answer a simple question like find all communications for a set of user for a date range, right? It's very simple to do. Put a batch scanner in front of it, and then your application and the user are happy doing that. Now, on top of this, if you want to say, I want to find all the data in this result set which has LIBOR in it, adding that as dropping a filter in front of it, right? Obviously, you can make it more complicated and say, I want to count now all the results that are being written. So that's just adding your implementation of counting iterator. So it makes it very simple to implement these kind of things. And this is where the real power of Accumulo comes in, is that if you want to scale this, it's just a matter, you can scale it by, as your data grows, as the tablet server grows, you can scale this processing, because all of this processing is happening at server side. So it's really, really powerful when you have data when you have the amount of data you're storing grows beyond a certain point, right? And obviously, if you want to do more complicated or more computationally intensive calculation, you can put a Spark processing or whatever on top of that, and then the application or the API doesn't have to change at all. You just need to can add more complicated functionality here, and things will work for your user, right? So that's really powerful, and I really like that in Accumulo, and it's truly distributed systems. A last use case that I want to present, I'm kind of running out of time here, is how we use Accumulo for storing files of varying size. So in our system, we get file which is 1 kilobyte in size. We have file which could be 50 MB or 100 MB in size. So the first system that we built, we had Accumulo, but we were not using it for storing these files. We were directly storing the files in HDFS. And that's not fair with HDFS because it's known that HDFS doesn't really scale or has problems when you want to store a lot of small files, right? But we did it and see, because we are developers, we first try something till we break it for ourselves, and then we try something else. So we did it in HDFS, and then we moved to Accumulo. So what we did was, instead of storing files directly in HDFS, we take the files and we chunk it, and we store these chunks within Accumulo, and then we drop in the metadata about the files themselves, right? And we did for our use case, we did a quick performance test of how this fares with something like using HDFS. So the HDFS writes were for us about 20 milliseconds, and just moving to Accumulo file system, we dropped those writes to about 8 milliseconds. So this is not a very comprehensive performance test. Don't quote me on this or don't use this as benchmark, but this works for our use case. And the point I'm trying to make here, it's really, really simple to build a system like that on top of Accumulo, and that's very useful and that's very powerful. And that's another reason why we use Accumulo, right? So in short, right, you need to make sure that you understand your data. I cannot emphasize this point enough. Whether you want it or not, you have to. But in order to do that, you need to build systems or give systems access to your developers to data in real time, right? If it takes them 50 different approvals from 5 different levels of people to get access to 2 GB of data, then you're not going to get any work done. So it's really important that your developers have access to the data when they need it, right? But obviously, you're talking about data, so you need to have some kind of access control. And if your data pipeline looks like this, it's time to rethink your life, right? So please, and we have been in that state. All of us probably have been in that state. I for sure have been in that state where my data pipeline looks like that. And that's why we started thinking about moving to and building a new system. So if that's what your case is, think about how you can redesign and rebuild the system. We think that Accumulo is a very, very interesting project. The community has done a great job of building the system and open sourcing it. And I can't thank you enough for it all, right? We are doing a lot of work on this. There's still, and if you want to talk to us, if you're looking to work on Accumulo, we are obviously hiring. So this is my hiring pitch. There are a bunch of Bloomberg folks in the conference today, so come talk to us. They're sitting there. Come talk to us. Just you want to talk technology. If you're looking for a job, talk about anything. Right? Thank you. I don't think I have time for questions, but you can catch me anytime. Thank you.